Before I welcome our guests, I'd just like to invite those who have not already done so to please subscribe to our YouTube channel, Magnimind Academy. We upload recorded sessions of these talks so you can watch them later. Also, you can comment any questions or just thoughts in the comment section below, or just let us know what you think about the Zoom format in today's talk on the YouTube comment section. Thank you. Now I'd like to welcome Garrett Smith, who's presenting his talk on the 10-second rule, how to maximize your productivity in ML. At Magnimind, we really try to find speakers who can give these kinds of talks and give a little bit of a different information or a different perspective to go along with our data science education programs. These programs range from focusing on the fundamental skills of data science all the way to helping bring your entire career change into the industry. Our goal at Magnimind is impacting as many careers as we can, and this is just one way that we do so. In this talk, Smith will be presenting a way to shift the focus of your work in order to optimize your productivity. He has used his own techniques with his company Guild AI, which develops the tools needed for engineers and researchers to build new software and AI systems. Before this, he has also founded 2 other companies and has had a career for over 20 years. Graduating Macalester College with a degree in economics, Smith has worked mainly for startups, and he can bring an insight into this world and how he was able to implement a new philosophy into the constant grind. We're very excited to have him, so now please give your full attention to Garrett Smith.
Thanks, Thomas. So I appreciate this opportunity to present this topic. It's extremely experimental. It's probably one of my more experimental presentations, and I've had a lot of weird ones in the past. So, we'll see how it goes. I feel like there's a lot here to be passionate about, but this is definitely novel. And so bear with me if it seems a little strange at times. Let me share, and we'll get going here. Okay. Let's just do this. Okay. Okay, so I'm going to be talking about the 10-second rule, and a lot needs to be explained here, and it's a little bit more complex and detailed than simply make things go under 10 seconds. So if you came here with thinking this is going to be a short 15-minute presentation on, hey, just make your operation short, I'm going to disappoint you. It's going to be way more involved than that. And we're going to get into some things that kind of go off the reservation potentially. Okay, so Thomas did a great job introducing me, so I'm not going to spend much time on this. I'm starting to get active in the machine learning, data science, Twitter sphere. My history has been in sort of programming and functional languages and Erlang, and most of my kind of connections are in programming circles. And lately I've started to chirp about things ML. So if you're interested in any of this stuff, the more of it's going to be coming. So follow me on Twitter, and you'll see what comes up there. Okay. So this presentation, I'm going to cover the 10-second rule. We're going to get through that pretty quickly, and then get into a specific methodology. And you will see a fairly detailed step-by-step, blow-by-blow on how to do this. And it turns out this is not nearly straightforward. This is a fairly complicated. The idea is very simple, but tackling it can be a bit complicated. And so we're going to get into a fairly detailed methodology. I have a live coding example. I prefer code and especially live coding where things can go wrong. So we'll spend a lot of time with Python and discussing the specifics of what I'm doing there. So this is not just going to be a slideshow. And then get into some of the higher level importance of measurement, why we want to do some of these things at a higher level, and then I'm going to wrap up. Okay, the 10-second rule is really simple. It comes from Radek Osmulski from this Medium post, How to Do Machine Learning Efficiently. I'll make sure that these slides are available, but if you just Google that, you'll get it. And it shows up in the front part of the blog post. And it's simple. Don't ever let a calculation exceed 10 seconds while you work on a problem. And so I saw this, and not a lot of people are talking about this problem of be thoughtful about efficient work in data science. There's a lot of introduction to data science. And when I say data science, I'm going to kind of leak from data science to machine learning. To me, it's, what I'm talking about here is the application of data to software problems. So I am approaching this from a software engineering point of view. It is very applied. So I'm not really talking about research so much, though this absolutely applies to research. But my brain is all about building stuff. So, my areas of interest are taking these methods and applying them to software development. So I'm going to have a heavy slant to that. If you're in research, I apologize. I don't mean to slight that. This is just my sort of leaning. This definitely applies, though, in every facet. So this is the premise, and I got excited, and I liked a lot of the things he had to say, and I feel that this is worth repeating, and I feel like this is worth elaborating on. So the obvious benefit is that you spend less time waiting, and you're less distracted. And if you've ever done any of this stuff, you know that you can spend even 10 or 20 seconds waiting around for something is enough time to kind of start checking email and doing other things. And when you get into deep learning and other long-running operations, your productivity in terms of scheduling experiments becomes quite a problem. Experiments tend to, or training operations can tend to run from hours to sometimes days. So obviously you're not sitting around and sleeping like this guy. It's a general problem, but I think that this problem exists even with classical machine learning methods. And anything that exceeds 10 seconds is really suspect, and you want to address that from a purely the standpoint of, hey, I don't want to spend time on this. And you might think this is common sense, and I think it is, but there's a lot of wait state involved in data science. So this on the surface addresses that, but I'll get into a little bit more. Some other benefits, but just take a look at the science of what I call the science of waiting. There's a question, why 10 seconds and why not 5 seconds? Well, the main reason is I'm sort of riffing on this article, and he says 10 seconds, so I say 10 seconds, and maybe another person says 10 seconds, and all of a sudden everyone's saying 10 seconds, and then it's just 10 seconds. Or if somebody says 5 seconds, we pivot and it becomes 5, whatever. Getting into the actual science of waiting, there's an interesting amount of work. There's a lot of research on this topic, and especially lately when it comes to websites and web experiences and how long somebody's going to tolerate waiting around for something, usability studies for software. So this is a kind of an oldish study, and there's things that go back to the 60s. So there's a lot out there. Here's a breakdown from this particular source. 100 milliseconds, so 1/10 of a second, is perceived as basically is instantaneous. So there's really no sense of waiting, and there's no need to show progress or anything like that. 1 second is sort of the upper range for somebody's limit to stay the flow of thought to stay uninterrupted. And then they cite 10 seconds as the limit for keeping users' attention focused on the dialogue. Now this is related to a website, but this is cognitive measurement, so one presumes it would apply to all sorts of things. I can tell you from personal experience that 10 seconds is an extraordinary, for me, it is exasperatingly long. So I'm definitely closer to the 5 second mark. So the answer to that is maybe it should be 5 seconds, but 10 seconds here seems fine too. It's round. This is an interesting quote. Short-term memory plays a critical role in human information processing. Interference with short-term memory can occur when an individual senses an awareness of waiting after approximately 2 seconds. I think this is quite accurate. I feel like 2 seconds is really long enough where I'm like, what's going on here? And if a website is more than 2 seconds, I'm starting to notice and probably getting a little irritated. Certainly in my own work as a programmer, 2 seconds is an extremely long time. So we're going to see here the work that in this example, I'm going to try to get the operation way below any of these, like milliseconds. We want to try to get milliseconds so it appears instantaneous, and there's no sense of waiting at all. Okay, before I get into that, though, I want to talk to you about kind of my underlying motivation for this. I think that the idea of saying, hey, let's try to shave off, 10 seconds here and 15 seconds here. It's not like a world-changing view, right? It's not that big a deal. And if you were sitting around waiting for 30 seconds, you've probably already taken some action. You're not really wasting that much time. You're using the time. Maybe you check email. Maybe you go have a book. or maybe you have another project, you do your best to have an efficient utilization of time. There's a different benefit here. And I'm going to reference this quote from Linus Torvald. Now, Linus is obviously the creator of the Linux kernel, and sort of Linux is he's the namesake of Linux, the operating system. Obviously, Linux is a lot more than just the kernel, so people like to say GNU Linux or Linux, GNU. So we give credit for the GNU folks, but Linus is the guy behind the kernel, and really sort of the advent of the operating system and the success of the operating system. No, I shouldn't say that. It's GNU Linux. It's fair. It's evenly distributed. He also invented Git. So he's kind of a luminary, a creative luminary of our time. And he's definitely a hero of mine. And whenever he speaks, I listen very, very carefully, because he's not just brilliant technically. He's sort of socially brilliant. He's socially minded. And I think he's got a really good understanding of human behavior, and it's an important problem for him. And when he created Git, he set out as a goal to make it extraordinarily fast. So he addressed this problem of waiting around for stuff, just the same thing that we're talking about here, same idea. And his motivation was not simply, hey, make it fast for the sake of fast. So here's a quote that this is his quote from a Google Tech Talk in 2007. He says, Git offers a kind of performance that actually changes how you work. It's no longer doing the same thing faster. It's allowing you to work in a completely different manner. And that's why performance matters. So for me, this is a very influential idea. And the idea of reducing friction in some activity and encouraging that activity by removing points of friction is very, very important to me, sort of as a tools author. And I look for those opportunities. So if I feel like there's a best practice out there, I want to make that best practice super, super, super easy to follow. Otherwise, people tend not to follow it. They tend to take some other path. And I think performance and how much you're waiting for an operation has a lot to do with that. So I'm using that sort of as a platform to talk about this broader problem of designing a workflow that lends itself to the right sort of practice, that sort of draws you into behaving in a more efficient, more effective way. By the way, in this particular point, the performance topic had to do with merging branches. And so Linus observed that in distributed source control management, one of the problems before Git was that it was very expensive not to branch, but to merge branches. And as a result of that, people tended not to do that. So he said, I want to solve this problem. I want to make this so fast that people are they won't even think about branching and merging. And indeed, that is the cornerstone of the success of Git. People branch and merge without thinking about things. And we have this really remarkable distributed ecosystem of people working on source control without a central control. And this is really, I think a lot of this can be attributed to the technical focus that Linus put into Git when he designed it. Okay, so now I have the job of taking this kind of principle of making something easy to use and applying it to ML. And I'm talking about the 10-second rule. But really what this does is it teases out a way of working that focuses on operations. So when you say 10 seconds on what? And that what defines the thing that you're working on. And so we're going to see this sort of in excruciating detail with these live examples. So this slide may be a little bit abstract. So please don't expect to get all of this. This is more of a prelude to what hopefully will be communicated through an actual example. But an operation, just to sort of foreshadow this, is something that you do that has some inputs and outputs, and you have some notion of what is correct when you run it. And that's going to be very central to this idea of implementing a 10-second rule. And when you can do these things very quickly, it starts to open up what I'm going to call the exploration frontier in the explore-exploit trade-off. So we'll see this. I realize this is kind of from left field, these points. So it is kind of intentionally not rooted. So don't worry about that. Hopefully it'll make sense when you see some examples. Okay. So here is the 10-second methodology. And incidentally, I don't do well looking at chat windows and also my train of thought. So I've asked Thomas to keep an eye on the Q&A window and the chat window. So if you have a question, just type it in. Thomas will see it. He'll interrupt me, and then I'll answer. I prefer questions during a presentation. Otherwise, I get bored. Right? I start to get in my own head, and I start to fall asleep like that guy on the counter. So keep me awake, keep me honest here. If I'm saying something that doesn't make sense, or you'd like some more information on something I've said, please don't hesitate to type a question in, and we'll get it answered. Okay, here is the 10-second methodology. So it's a bit of a slide. There's 7 easy steps, 7 easy, simple steps. So let me go through these with you. I'm going to return to this as I do the example. So don't feel like you need to furiously write these down. The slides will be available, but we're going to go back to this time and time again. But let me just cover this stuff. So the first thing in this sort of experiment, this idea of running things quickly, is to do no harm. And this cannot possibly be overstated. It's the reason it's number one. It's not really a step. It's more of like a mental, point of insistence. It's like a stopgap. You have to maintain this at all time. You don't want to go into your code and start mucking around with these, let's make things go fast if it's going to break your code. So it's really important to tread lightly and smartly and carefully in this area. So we'll see some method. We'll see some ways of doing that. So I have here, you want to preserve the default value, avoid changing lines, so you only add lines, and you make your changes obvious. So I'll show you an example of what I mean by that. Step number 2 is you put on a development mode hat. This is, again, not really a step. It's more of a mental state. You're going to have, in order to achieve this 10-second rule, you're going to obliterate any notion of accuracy in your model. So you're not really going to be doing machine learning. You're just going to be running code as fast as you can, and your numbers are going to be terrible. Please don't worry about that. That is intentional. If your models perform really, really well after 500 milliseconds of training, something's probably wrong there. So you really do want to expect your accuracy to just plummet here. So understand that what I'm presenting here is a mode of work. It is not the final product. That maybe that goes without saying, but I just want to underscore that. Okay, number 3, we want some idea of timing. We can certainly use our intuition. We know what feels long and what feels fast. But it's never a bad idea to have some timing instrumentation. We're going to start out in a notebook example. It's very easy to instrument a notebook. We're going to move to a different format. It's fairly easy to instrument that. So you're going to keep an eye on how we're actually measuring the time we spend. And so this is my technique, and this is kind of what I'm proposing. Step number 4 here is you define some sort of flag, and I use this underscore 10-second flag or something like that. And you set that as a flag. So it's a true or false flag. And then you define your time-related parameters. Sort of you pull them out so that you can modify them. And I'll show you an example. So that's number 5. And number 6, in a conditional block, you modify these parameters based on that flag setting. And once you have that configuration in your code, you can start to iteratively develop. Now, as an example of what not to do, I'm going to actually pick on Radek here. I really don't think he's on here. If he is, I'd be quite honored. Maybe he'll see this someday. So I have to apologize, but he makes a recommendation here, which is very similar in the goal, in sort of what we're trying to achieve. But I think his recommendation is not good, and that you should not do this. So his recommendation is that you have sort of duplicated code blocks here, and that you comment and uncomment the code as you need to enable it and disable it. If you do this, I absolutely guarantee, unless you're just stupefyingly lucky, is going to result in a bug. You're going to forget to uncomment something, or recomment, uncomment or comment something. You're going to have comments all over the place, and you're going to pull your hair. I don't think he uses this method. There's no way this is going to work. So I'm proposing something here that I think it has the ability to actually work. Okay, So what I'm going to do as an example, let me come back to my little guideline. So I'm going to come back to this thing. Here's my live example. So let me keep my rules up here, and I'm going to start with this bit of code here from the TensorFlow for beginners. This is this snippet, and I literally just copied and pasted this. So that's the reference. Here's the actual code in a notebook. If you've seen this before, I apologize. Yes, it is MNIST. Yes, we're all sick and tired of MNIST. We could have used fashion MNIST. We could have used something other than handwritten digits, but you know, this is the hello world. You know, we've typed hello world our whole lives, and MNIST is here to stay. This is going to be with us for a long time. It's going to be rare that we do our hello world with ImageNet, and not anytime soon. Even though Google would like to make you think that that's possible. So we're using MNIST, and we're doing a very straightforward multi-layer perceptron with an input layer, an output layer, and basically a single inner layer here. And we're using the standard data, and this is something that it's sort of pre-configured with. It's pre-split between test and train. We're using an atom optimizer. This is Keras, and we're just running a fit operation here, which is your training run over 5 epochs, and then we're going to evaluate that. So let's go to our list. I'm going to close that, and we say do no harm. All right, so keep that in mind, and we're going to put on a development mode hat. That's fine. We keep that in mind. First step here really is to add the timing instrumentation. So I'm going to add this magic here, which is time. All right. And I'm going to run the cell. Up. Space problems. Okay, so I'm going to run the cell. And I'm already getting super irritated. And we all understand that these toy examples are not really real work. If you're doing classical machine learning, this is probably a fairly this would be considered long. And there's you can do a lot of work across a lot of data, a lot of examples with a simple model. So as models go, this, you know, depending on how simple you mean is simple, this is maybe medium to light. If you're into deep learning, it's trivial. It's the simplest possible model that you would consider. It's not really even that very deep. It's got a single inner layer. So these get a lot more complex and a lot more time consuming. So I appreciate the absurdity of taking even, what do we take here, 30 seconds on a deep learning problem. I get that. All right. This is representative. So you know, this could be 300 or 3,000. What I'm about to do here really should shave your time down to the less than 10 seconds. Certainly will in this case. Okay, so I know how long that took, way too long. So I'm going to define this 10-second flag. And that's just this simple. I'm going to use it up at the top. Sec is equal to true. I'm going to turn it on to start. Okay. Now, this is very arbitrary. I just pulled this out of thin air. Why did I do this? Part of this was in the spirit of to make these changes obvious. This is such an odd thing that it begs the question, what on earth is this? If you happen to have seen this presentation, you know what it is, or otherwise you can just add a comment.
Oh, Garrett, I have one question for you. It's when you say avoid changing lines, only add new lines. Does that mean to correct a bug, you copy the line and comment out the original?
Well, it's okay. So let me differentiate between the project payload, which is what you really want. Nobody cares about this 10-second stuff. This is nonsense. You should be able to strip these out easily and definitively, and sort of quote unquote restore your code to its pure payload. So this is to some extent noise, and it's wrong. We're gonna break this stuff in order to get us running fast. It's a very strange. It's kind of a strange thing to do. So if you're talking about a bug, no, you fix that bug. You definitely don't want to keep history around. Just fix the bug. What I'm talking about are the specific changes to make things go faster, simply for the sake of making them go faster, so that you don't have to sit around waiting so long. That you should add. So, and you should do it in a way that I'll show you as an example. So as it turns out, I'm going to actually make a lot of changes to this code, but it's not going to be related to the 10-second rule. It's going to be related to what I'll call the project payload, the actual code that I want to write. I'm going to improve the code. I'm going to refactor it as I go. But this 10-second stuff, I want that to be obvious, and I want it to be separated so that it's easy to spot, and it's easy if you wanted to delete, if you wanted to get rid of it. Does that make sense? Everyone's furiously typing.
Yeah.
Usually that's a very easy question to ask, and I can just see everyone's nodding. Does it seem like everyone's nodding out there? Okay. So my next step here, that was easy. All right, I defined this flag. Really simple stuff. The next one is where it gets interesting, and this is where you need to reason about how, in your particular example, you can make things go faster. The obvious target here is to not do this thing 5 times, but to do it one time, and that's the epoch. So that would be the very, very first thing that you would look at in a training operation. Now, if you're doing a data preparation operation, if you're doing some other, some other kind of compression or something else, then it would be something different. But most of the focus in machine learning is sort of centers on the training. So this is very logical. So what I want to do here, and I say define time-related parameters, preserving the default behavior. So what I mean by that is this is hard-coded. That 5, that's hard-coded. That's really a hyperparameter. So I want to expose this by doing this here. Epochs equals 5. I'm setting at 5 because I want to maintain the default behavior. Hyper parameters. I'm going to just comment this. I'm going to start to fill in this list eventually, but right now I'm just interested in kind of this 10-second. I'm going to do one first pass at the 10-second rule. Let's get rid of that output. Okay, so I've exposed the thing that I want to control here. That's the epoch count. How many epochs I'm training over, and an epoch is just an iteration of training that covers all of the training examples that you have in your data set. And you generally run multiple epochs because you are trying to move weights around, and your model needs to see training examples in different order and repeatedly, and you often add data augmentation. So you run for many, many, many epochs. So in this case, we want to run for 1. Now, what I'm saying is in a conditional, for 6 here, in a conditional block, set the 10-second parameter values. And this is sort of where the magic happens. We're not into rocket science just yet. This is sort of intuitive, hopefully. If 10-sec, then epochs is equal to 1. All right. Now, I had this sort of redundant, I'm defining this up here. I could have said if true, right? That's a little weird looking. What I'm going for here is a single flag that I can turn on and off. When I turn it on, this thing should run with blazing speed. When I turn it off, it should run normally. It's as simple as that. I don't want to have to think about it. I don't want to have to go searching code, reason about code. I don't want the slightest thinking involved in this, because we're right on a knife edge to begin with. This whole exercise, we're getting into our code and changing it in really perverse ways. You'll see in a moment how perverse. So I don't want like layers of complexity here to enable and disable it. I want a simple flag. It's on, it's off. It's on, it's off. So in here is going to be the conditional logic of modifying my algorithm, my program, through changing parameters or modifying state to make this 10-second rule apply. Okay, so with that, now 10-second rule is enabled. I'm going to run for 1 epoch rather than 5, and I would expect this to now go much faster. All right, it's still extremely irritatingly long, way too long. I don't want to sit around for 7 seconds. Nobody should be subject to that. So now I'm going to think, how can I make this go faster? Well, if I could change this to maybe the training steps, where it would just say, how many examples do you want to train on? I could do that, but Keras is kind of wired for epochs, and frankly, you should be wired for epochs. But I can effectively do that. Here's the second suggestion, by looking at my data set size. Now, the MNIST example, I think, is 50,000 or 60,000, somewhere around there. We don't need to train over that many. Again, we're just trying to execute our code path here as quickly as possible. So we're not concerned about accuracy. This is a wonderfully high accuracy for a single epoch, but I don't care about that number. So what I'm going to do here is I'm going to move this conditional block down after I've loaded the data. And I'm going to modify, and this is the perverse part. Now, shield your eyes, because this is really horrible. And you can appreciate why I want to put this under a conditional block. And here's the horrible part, right? I'm not randomly sampling this. I'm just lopping it off. X, what I want, a Y train. Y train, and then for symmetry, oops, I want X test, and then I want Y test. Okay. So I'm just going to review this. This looks pretty good to me. All right, so now I'm going to run it. Okay, now 1.6 seconds, that seems long, still seems long. I'm wondering if I have something running on my machine here. I feel my machine is, oh, Zoom is running. Zoom is running, and it's occupying approximately 300% of my, 250% of my CPU. So that's why this takes so long. All right, well, I'm running a pretty fast machine here. And in my tests earlier, it was like 700 milliseconds. Now it's 1.5 seconds. Okay, that's still not too bad. This is about as fast as I can get, short of getting into this data load. Now, if you're doing that, if you're interfacing with a database, if you are loading 1 million records, you've got yourself a very serious I/O problem. That's going to take a long time for you to load that data. You would apply the same rule, the same pattern into the data loading phase, where you might load 100 examples rather than 1 million. And you might have to pass this parameter around, or you might share this parameter. You might put this in a shared module with some global configuration. Every project tends to have a configuration strategy. I happen to be using global variables here, but others might be using command line options, or they might be using global dictionaries, like a params dictionary. They might be using a JSON file. You'd have to apply this to your particular configuration strategy for your particular project. So this rule does not apply in all cases. I happen to be taking a very simple path here because I have a simple example. Okay, so let me slow down just a second. There it is. This is really sort of the gist. And I've set myself up here for the final and most interesting, which is going to be to start developing. So I'm going to make a few more changes to this to take kind of advantage of my new superpowers and running this thing quickly. So any questions about what's going on here and why I'm doing this?
There is one question, which is, what is the goal here? Is it to minimize time needed to make sure the model compiles / performs reasonably?
Yeah. So the Uber question, or the Uber answer, is it sort of depends on what your goal is. My goal right here is to make sure that I'm running complete end-to-end code path every single time I run this without sitting around waiting. Now, this happens to be the long pole in my operation. So really the trouble spot is after that. This is a trivial line here. So this isn't the best example. In fact, I'm not going to modify this at all. I'm going to actually start refactoring some of this stuff, which would not really cost me anything. But the idea here is that I don't care. I want to run end to end every single time with in under a second. Zoom is running, so I can't easily right now without hacking this stuff up. So to answer your question, in this particular case, it is to run the full code path. So all of these are executing. So if I have a shape problem here, for example, so let's make this shape invalid. Right, this is going to show up immediately. It would have shown up immediately anyway. So again, this is kind of a bad example. But let's say this is where I saved all my time in this 10-second rule. That's very legitimate, right? I pass this in and I'm loading much less data. And this is the thing where I had to wait 5 seconds or 10 seconds to load this data. I would have had to wait 5 or 10 seconds to notice that particular problem here. So that's the idea. Okay, so while I'm in here, what I want to do is I want to pull out some hyperparameter. Something bothers me about. I mean, I realize that Google's doing this to have a very small and tight example, but many examples tend to do this where extremely important hyperparameters are either hard-coded or they're implicit. They're defined someplace, but you don't see them anywhere because they're defaults. So one of the things I like to do as I'm developing and if I'm working with other people's code, which I do a fair amount of as an ML engineer, I like to sort of pull these things out and make them parameterized. So A, I can see them, and then B, you can kind of experiment with them. So we'll see this a little bit later. But dropout is a very important hyperparameter. So I'm gonna put this out here. And
we do have one more question. It's more of a critical one. What is the purpose of what we're doing if we get a very low accuracy?
Right. So let me answer that. Right. Okay. So there are two things that you're doing here, and let me highlight this slide, which is this. This is true. This be nervous is true when you're using Python. Other languages that are strongly typed languages, you don't have to be as nervous. But the advantage of Python is that you have very low bar to a compiler running your code. You can really run anything you want to. And the only way in Python, this is just a hard fact, the only way to really trust your code is to run it and to observe it. People have tried to do inspection and extraordinarily complex things with the interpreter and examining code, and this is true of any interpreted language, in particular dynamically typed languages. You can't. It's an intractable problem. The only way to have any confidence that what you're doing in Python is right is to run the code, observe the outputs. And that's how testing runs in Python. You don't really have, you can lint, you can do type hints. These are moving things in the right direction, but data scientists don't do that. So really what you're talking about is running. And what I want to do is I want to run as quickly as possible. Again, this was number 2. Where's my number 2 here? This is a developer mode hack in this particular mode. Abandon all goals for accuracy. You're not trying to get high accuracy. You're trying to build your model, right? I'm in the middle of a development effort here. So, later, once I have some idea that the structure of this code is sound, then I can reset this thing and let it run and see. And in fact, we'll do that. All right, so just to repeat myself here, I want to run this as quickly as possible and observe the results. And there are 2 types of results. There's this meaningless accuracy here. Well, that's pretty good. That's just luck. If I run that again, it's not going to be that high, guarantee it. All right. This is meaningless. But the fact that this ran successfully, that's very meaningful. it means that at least I didn't break the code, well, much. I mean, it looks so, I mean, let me break something here. So I'll play with the shape because it's easy to create an error. All right. So if that had been after one of these long running operations, I'd simply have to be sitting around waiting for that. That's a type of model improvement here that you do in development mode when you're just trying to glue the things together and make sure that the thing runs through successfully. So we're trying to shave off those expensive, pointless cycles in training for accuracy when you don't give two hoots about accuracy, when you're trying to create the layers and get these layers to hook up correctly, given your data set.
We do have one more question. Instead of reducing Epochs data set size or model size to reach 10 seconds, what would you think of using a cloud service with an NVIDIA DGX Graph Core server or Cerebras system?
Well, if you really, really want to increase your wait time, start using cloud services. I mean, just do it as an experiment and see how that works for you. You may find that it does go faster. It isn't very green. You're doing a lot of work for absolutely no reason. If your goal again is to sort of get this code correct, and focus on the assembly of your code. There's the data science, and that's important, but you have to go through the program to get the result. And there's a lot of mucking about in that. And now, in my experience, the last thing on earth I want to do is make a change and then upload it to a server. Some people do this, but I feel like it's an incredible waste of time if you could accomplish the same thing running it locally. And indeed you can. It's not that hard to configure in these cases. You kind of look for your log. Now, if it turns out to be that hard, okay. If you find that this is just not going to work for you, sure, go ahead. And certainly when you're actually doing, you're running your production workloads, for sure, no question. You use the compute capabilities that you can use. Not everyone can run things on their laptop. Not everyone can run things on a V100 sitting in your desktop someplace. You need to go to higher end accelerators for sure. There's no question about that. Not even a slight hesitation. But what you do want to make sure is that once you do that upload, you want to have a fairly high degree of confidence that your code is going to run through to completion, and you're not going to get silly mistakes along the way. If you do this work enough, you'll see, you upload something to a service, you wait 2 hours, and you had a dumb bug along the way. And now what you're doing is you're spending time, and you should probably do this anyway, but you need to be doing checkpoints and restoration and recovery. That is definitely part of this. But I think a lot of those bugs you can find immediately by simply taking this method and running your code over and over and over again as you are refactoring. All right. So there are a few other hyperparameters that I want to just take a moment and expose. Learning rate is nowhere to be seen here. It's part of this optimizer. And I'm going to go ahead and look this up because I can't remember it. Keras Atom Optimizer. All right, so Keras is sort of this flexible framework that lets you use a string value to specify your optimizer, which they do here, but you've lost the ability to specify any of the hyperparameters associated with that optimizer. So I'm going to just put this in here like this. So my learning rate is this. I need a comma here, and of course, I need to expose this. Okay, that's the default learning rate. Okay, so did I make a mistake here? I'm just going to run it. This is in the spirit of test-driven development. I am keeping an eye on the fact that this is not that this is being printed at all. That there's not an exception being. I'm not taking the accuracy in the slightest bit seriously. Again, because I just want to exercise my full code path in this case. There's another set of hyperparameters involved here, which you will, if you work with these simple neural networks, I feel like you want to almost always design these with the size of your inner layers configurable to some degree. If you're new to neural networks, I don't have a tab. Let me open this. So this is a TensorFlow playground. This is an aside. This has nothing at all to do with this topic. But those who are new to neural networks, I suggest you become familiar with neural networks if you're not. This is easily the best illustration and learning tool for a fully connected network that I know of. This is a live playground that you can work with, where you control your inner layer, your input layer, your output layer, and you have these simple tasks, these simple problems of classifying orange or purple based on or within some distribution. And sometimes the distributions are very simple. Linear model handles that, and others are quite complex. The distribution that we're dealing with is a distribution of handwritten MNIST data set, the Lacoon data set, which is far more complex than this, but this is fairly complex. And to solve this, to learn this distribution with any degree of accuracy, you need to kind of add some capacity to your neural network. And so what you end up doing is tacking on and adding the ability for you provide learning capacity. So this handles all sorts of complex nonlinearities. Maybe you want to use a ReLU here, and then you can learn from that. And if you play around with this, you start to sort of get an appreciation for the balance between the size of the network, how fast it learns, and the problem that you're facing. And this is all literally running here in JavaScript. So it's very concrete, and I think it's a great way to get your head around the problem. So without these additional layers, this doesn't learn.
We've actually got one more question. Sorry, it's real quick. I suspect you'd recommend not using if _ 10 second, short else, or regular code. I
didn't quite catch that.
Oh, sorry. It's I suspect you'd recommend not using if _ 10 seconds, short else, or regular code.
For regular code?
Yes.
Well, I'm not sure what you mean by regular code. Let me get out of this thing, come back to our code.
Oh, he says i.e. using product code in else clause.
I'm still not.
Oh. Is it using production?
Oh, you don't want to use it in production. Is that so you, yeah, right. No, you definitely don't want to use this in production. This is this is why this is such a funny looking thing, and why I'm taking a lot of care and trying to break this out. This is like a pure development mode. You don't want this anywhere near production. So this goes off. This goes to false. Yeah. So I don't know how else you do this. So I mean, what's at stake here is you're always sitting around waiting for something. Right, so the temptation is going to be to set your epoch to 1 anyway, right? So you're going to go up here and set it to 1. All I'm doing here is doing this, but giving you a more extensive lever to reach through the entire end-to-end program. Anything is in play to keep this operation short. And again, so that you execute the full code path with no regard to result in order to test changes. So if you did not do this, what would you do? Would you really sit around? What if the default happened to be 20, which it is in many cases, and you're sitting around for an hour? You certainly wouldn't be running that. You would change it. You would change it to 1. You would do that anyway. This consolidates that logic into a single flag. Now, I don't think that's controversial. I don't know what you would do otherwise. The recommendation here from Radek is to comment things out. I think that is a disastrous proposal. I want to see one, and I don't mean to be mean there, but I mean, imagine forgetting to uncomment something. I mean, just you know that's going to happen, and you're going to have a mess, and you're not going to really know. This, at least you have the ability to set a single flag, and then the fact that you're only adding, you're seeing sort of the obvious breakout of this code. I think gives you a pretty good chance of managing this and not introducing bugs accidentally. Why would you introduce a bug intentionally? Okay, so let me add this inner layer, and then we're going to be done with this. I'm going to move on to some other topics here. Okay, so what I want to do here is I want to take this thing, and I killed my tab, but I want to be able to do the right. I want to be able to add and remove layers as a function of a hyperparameter configuration, right? So I want to say I want more layers or I want fewer layers, and I happen to know that is part of this architecture, and it's not really reflected here, and I kind of think it kind of ought to be. Okay, so MNIST is a benchmark data set, and we know what this is going to do. We have absolute certainty that this is going to work. This is a very, very effective model to get 98% accuracy without a lot of work, but it's a toy example. If you're doing this with your data, it's a novel data set, you don't know. I guarantee you don't know what's going to happen. So you're going to be in experimentation mode. So when you look at your model, you want to look for opportunities to parameterize that model and give yourself an opportunity to experiment. All I'm really doing here is taking this concept here, this parameterization, extending it, and allowing myself to refactor this code very, very quickly, or test the refactor without sitting around waiting for a lot of time for stuff I don't care about. So I'm going to change this. The way they have this configured is doesn't lend itself to what I want to do here. So I'm going to use kind of the more traditional Keras. If you're familiar with Keras, this is typically how these are built. I think that Google's example, they're interested in brevity or something. So let me define this. So hidden layer count. I know the spelling error there. I'll fix that. Default is 1.
We do have another question.
Uh-huh.
It sounded like the previous question was, could you put the production hyperparameters in an else clause of the if _ 10 second rather than being assigned before the if _ 10 seconds?
Let me, is this in the Q&A? Where is this question?
This is in the chat.
Chat. So where is this here? Chat. There we go. That's what I'm looking for. Okay. Because I'm not understanding that. Sound like the previous question was, could you put the production hyperparameters in an else clause of that? Oh, okay. So yeah. Okay. I understand now. Yes. And that's exactly what you said. So I wasn't getting my head around that. You sure could. So you could do that. But that's a case where, so what I want to do is I just want to be able to, I want to know that this is a specific hack. I don't want this to be really like a legitimate part of this code. You could certainly do that. So the question is this, why don't we just do this? Can we do if 10 second, then this thing, la, 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 otherwise. Well, first of all, I'm not modifying every single one. Second, I don't want to complicate this. This is pure, nice. This is what I want. This is what I'm calling my project payload. This is legit. This is all nonsense. This is total nonsense. I can just delete that thing, and now it's working, right? It's clean. It's just, you could put some sort of massive weird comment block around it. My system is really under duress thanks to Zoom here. Right? So this is the idea. I don't want to intermingle this logic. That's the last thing I want to do. I want to keep it separate. So that's why this is like a monkey patch. So if you're familiar with the monkey patching pattern, you have your core program, and then you layer your monkey patching on top of that by hacking away. If you want a monkey patch. You could almost do this from an external module, right? So you have your module pure here, and then you have another module that goes in Python. You can do that very, very easily. It's wonderful. You can go into Python and muck with the namespace here and change all these things. Now, for this example, I'm just using this as an approach for this example. Now, I want to keep it as simple as I can. Okay, so let me add these layers, and we'll be done with this. I'll test it. I'll show you it runs quickly. I'll restore it, and then we'll move on to the next topic, which is, I think, for me, the more interesting stuff. But let me just get this in. So I want to say range hidden layer count, and I think what's going on here is my keyboard is responding badly because of the Zoom lag. Okay, so what I want to do is I want to add, for every hidden layer account, I want to add model. I want to add this this is really a single layer. It's a layer with a dropout, and it's just implemented as 2 layers. Okay, this is hidden layer size. And then I want my last layer to be this. Okay. All right. Now I don't really care. I'm not going to read this very carefully. I'm just going to run it. And I got an error, so that's fine. And again, I keep sort of making this point over and over again. It simply happens to be that this is the long pole. The long pole for this could easily be up here, right? At which point I would have sat there for however long before I got this error. So this is really quite I think this is an important consideration when you're building this stuff. So a syntax error is not going to run at all. So bad example for in range. All right, so here we go. Okay, good. I got another. So so that's not defined. That would not be a syntax error. And it would be here. Repeating keys are just not working under this. All right, so run. I'm having all sorts of problems here. Add. Okay. Okay, so then it ran. So what am I doing here? I'm in a refactoring mode that is, a lot of times, you might be tempted to break all of your code out into separate cells so that you can run, you can be done with a certain operation. I'm kind of deliberately not doing that. I find it's a very, 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 very common pattern in data science, and it's pathological because it pulls you away from what I think is a very important construct, and that is the operation. And so I want to highlight that right now. What I've been doing is I've been running an operation. I happen to be running it very, very quickly. It's arguably multiple operations. You have a prepared data phase. This is a data preparation phase. It's very simple, but it nonetheless is a data prep phase. You have a training phase, an operation, and then you have an evaluate. These could all potentially be different operations, and they often are. In deep learning, you will always see evaluate as being a separate operation because you tend to run training and then you run an evaluate in parallel as your model is training, typically on a different GPU, so you don't slow your training down. Any of the Google deep learning examples that you see will have evaluate as a separate operation. So as things get more complex, you're going to, these things tend to be broken out as separate operations. So I'm treating this kind of as, in this example, as a single operation. And my point here is I want to run it fast. I want to run it end to end. And so that, when I do that, and I've made some refactoring, I've changed some things, what I've been doing in my brain is I'm looking at this output and I'm saying, yeah, this kind of looks like it's right. This looks okay. I guess this is working. So that's this. Where's my, that's this thing. Think in terms of operations, inputs, operations, and then the feedback on correctness. I've been doing that intuitively in this very ad hoc way. And that's no way to actually build software, because intuition only gets you so far and memory only gets you so far. This output here is handy sort of as a finger in the wind check, but it does not constitute a test. So my next phase here is I'm going to move this all into a structure where I can start to measure these things formally. And this is where I think it's maybe a little bit of a stretch to sort of argue that the 10-second rule enables this. But as you use the 10-second rule, you end up running these operations over and over and over again. I'm going to just turn this back on. You get in the habit of just running things end to end, all the way through. And this, lo and behold, starts to look just like test-driven development, which is a mainstay in engineering and has been for quite a while. And it's an incredibly effective way to develop because it allows you to make very small changes, see the results very quickly, and get some gauge as to whether or not your change is moving in the right direction or not. So I made a bunch of changes here. I ran it very quickly. It kind of looks like it works. And I'm going to do one sort of final sniff test with the 10-second rule turned off. And I want to make sure that I get an accuracy that's around 97%. So this operation point that I'm making, it's a bit of a step. I don't know if it's a stretch, but it's a bit of a long stride. And I think it might be very obvious when you start to use this and start to run these operations over and over and over again. The question is going to be, did I make a change that broke something? Did I make a change that made it better? Did it stay the same? And how do you know that? And if you can't answer that question, you should be very, very afraid and very, very, very concerned. And I want to get folks to the point where they can do these quick running operations and do it in a way that they have some degree of confidence that the changes that they're making are moving in the direction that they're aware of what direction things are moving in. Does that make sense? Does that, how do folks think, how do folks feel about that? You signed up for this talk about 10 seconds, and now we're talking about operations, test-driven development, and validating your results, inputs and outputs, that kind of thing. All right, I got one thumbs up. That's good. Okay, all right, good. So I just want to make sure we're, I'm going to take 2 as a majority vote here. No, feel free to continue weighing in. I'm gonna transition this into a little bit more formal structure here, and then I'm going to wrap up. I'm an hour into this, and people are. I'm okay. So I'm probably going to go a little fast, but all right, let's just do this. Let's do this. Okay. So I've been using a notebook here, and I think everybody in the room here should ask themselves, so I made all these changes. How do I know that this number, how do I know anything about that number? I happen to remember that number. But when you're doing this sort of thing, you've got lots of numbers, you're running lots of experiments, and you're keeping this stuff in your brain. I've made all these changes. How do I know which numbers are associated with what changes? Like, that's an extremely core problem. It basically translates into, do you know what you're doing at all? Right? I've been doing this as a demo and using basically a lot of kind of shrug, intuition, feels about right. Yeah, this looks about right. But there's no formal method here. This is Python. We can hack away all day. How do we begin to know that what we're doing is correct? The answer to that question, from my point of view, is you need to run formal experiments. You need to measure, and this is the same across all science. You don't just do stuff in science. You have a hypothesis, you set up a test, an experiment, you run the experiment, and you carefully record that experiment. And if you don't, I'm sorry, you don't know what you're doing. And I'm afraid, I know I'm sounding a little preachy here, I apologize, but it bothers me how rare how rare a systematic measurement of this work is in data science. We shouldn't call it science. We just call it data work, data activity. It's not a science. So I feel like what I've done here is not bad, but I cannot rely on my intuition for this. That's nonsense. So sure, I did all this refactoring, and I set myself up to run these quickly and efficiently, and bing, 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 bing. But the fact that I don't really know what is up, down, left, or right is of concern to me. So this is me being nervous. Let me get rid of this thing. I don't know if you can even see this. All right. How do you know change didn't break something? How do you measure progress? And how do you conduct a post-mortem? So if you got a funny result and something that you didn't expect, how do you go back and examine and dig into your work to figure out what actually happened? So one of the things you could do in a notebook would be, for every single operation that you run, would be to create a new notebook, because it's really the most convenient way to save this as a record. And that would be, I think, a very good record. You have your full code and you'd have your output here. And if you ever had a question as to what we did before, you could go back. Notebooks are stored in sort of diffable format, maybe not the best of strategies. But if you were to say, Garrett, I will always, forevermore, always do this work in a notebook, then I would say, what you might want to do to formally record an experiment is just to do a save as at this point. Create a copy of it. I don't think that may sound ludicrous to some, but I actually think it's a pretty reasonable approach. It's a little bit of work, but it's certainly better than forgetting what you did or relying on your memory. It gives you a record, and you can do a timestamp on it. You can do all sorts of funny things with it. But I think that gives you a pretty good shot at doing some form of experiment tracking. So that's an approach. The other approach is what I'm going to show you now. And how do I do this? I have to now share a different program. So what I'm going to do is I'm going to do, what do I do? So I did this before and it worked fine. And now I don't know how. New share, here we go. So, let me start up my IDE charm. So I'm an Emacs user. I like just plain text files. So I have a little bit of an austere ethos going. And I'm recently started to check out IDEs because I feel like notebooks are quite problematic. And I really like PyCharm. There's Spider, there's some other ones that do some pretty cool things. Let me share that and this, and then, all right. Okay. So I happen to have this. I'm going to make sure I have all the right code. All right. That comes from the notebook. All right. So what I'm going to do in this case is I'm going to show you a very, very primitive, but I think reasonable approach to doing experiment tracking. And what I mean here by experiment tracking is I want to add a little bit of measurement. I want to put the science back into data science. That's the most arrogant, lofty thing anyone's ever said. Is a little bit true, though. I hate to say it, it's a little bit true. I want to put the measurement into this. So, I've lost my slides. So you can't see these, but that's okay. I'll talk through them because I don't want to keep switching back and forth. Come on. Okay. So what I'm going to do is I'm going to use a very simple text-based experiment tracking system here. So let me show you just running this. I can run this. Sorry. Okay. So here is. So I'm running PyCharm here. PyCharm has an integrated terminal, so I can run command lines here. So I'm just going to run a command line. I'm going to run train 10 seconds. And this is literally the same thing I've been doing up to this point. I'm just running it with Python at the command line. So we're going to see our 10 seconds are off. Everyone can see this. Is that a fair assumption?
Yeah, I can see it just fine.
Where's my comments? Chat. All right, there we go. Good. Okay. So off we go. One of the neat things about a command line is you can do kind of cool things like redirect output to a file. So that's a little bit like saving something in a notebook, but now you're saving it to a file on disk, and it gives you the ability to, using Bash or even Python to automate that sort of thing. So consider this manual step. I'm down here. I hope this isn't too big. Let me make this better. I need to be so big. All right. Okay. Is the font size okay? Everyone can see this okay?
Yep, looks good.
Great. Okay. So, okay, my goal here is I want to capture this result. So I want to run the operation, and I want to quote unquote capture the result. This is a manual approach, and many of you probably do something like this already. So I'm going to create a runs directory. I'm going to delete the existing one because I did this as a prep. Make directory runs. So I'm going to introduce this concept of an experiment or a run. This is not a new idea. Everyone calls them the same thing. So if you hear experiment or run, it's one of these things. You're basically doing what we did in the notebook. So this operation, we're going to run an operation. Now we know we can run it quickly. So if we make a change, we can vet that change very quickly, no problem. But more importantly, we're starting to view it formally as an operation with inputs and outputs and some method of vetting it, testing it, making sure that when we change something, we know what direction we're moving in. So in this case, I'm moving this over to a command line environment, and I'm going to save this into a unique directory. And I'm going to say runs, and I'm going to say run one, and I'm going to call this baseline because I want to create a baseline measurement. The article referenced talks about this very methodology. So if you go back and read that article, that blog post on Medium, you'll see this idea reflected. I'm just taking this to a fairly systematic kind of, I think, a strongly vetted engineering perspective here. But it's the same idea. Because what I want to do is I'm going to play around with these hyperparameters, but I want to establish a baseline first to see what direction I'm going. So here's my baseline. So all I'm doing here is creating a directory, and I'm going to copy my source code over there. So I have a record of the source code. So if there's ever a question as to what was run, it's in that run directory. And all the hyperparameters are hard-coded, so I know exactly what was run there. And now I'm going to use this trick, this one weird trick called T. And T is a program that lets you simultaneously view standard output as you normally would, and standard error, and also direct the output to a file. So it's going to T the output both to standard output so you can visualize it, you can see what's going on, and it's going to write it to a file. So I have a record of it as a part of this run. So I'm going to do run one baseline, and I'm going to save this as output.txt. So when I was saying, you might want to do a save as with your notebook, this is sort of what you're doing here. Now that was three commands. I created a directory, I copied the source, and then I ran the operation. So really it's two additional steps. If you were to do this, I'm going to show you Guild in a second, which does that for you. So this is a bit of a setup, but honestly, doing this is very straightforward. People do this all the time. It's not, it's not that hard, and you could write a very, 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 very simple script to do this for you every single time you run something. So you just copy the code over, T the output, and you have a full record. So what we have here is here's our record, and we have our output. Our output is garbled because the progress report from Keras writes these status updates, but we have a formal record of our accuracy here on the last line. That's fantastic. Now I know what happened, and we have a record of the code. Now I know what I ran. Fantastic. So now what I want to do, not in this code, but in my actual source code is I want to play around with one thing. Let's just try training for, I'll do, curious. Let's see what the result is when I run for 2 epochs. And maybe I'll I don't know. I'll bump the learning rate down. So I'm not learning for very long. So here we go. So I'm going to do go away. Okay. So I'm going to make another directory, and this one's going to be called run2, epochs 2. Small, short train. I can name this whatever I want to. And I'm going to copy the source code to that directory, and then I'm going to run it again. Obviously, you don't want to be doing this every single time, so you write a little helper script to do this for you, but you can imagine how simple that script would be, right? So your workflow in this case, now you're not visualizing data frames, you're not doing plots, you're not doing the things that you typically would do in a notebook. You're just running these operations, bing, 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 bing. But you can imagine the workflow. You make a change here, you run an experiment. You make a change here, you run an experiment. Now, here's the cool thing. So what was my accuracy here? It went down. If I ever wanted to compare these runs without, where's my output? Did I not save? Oh, I forgot to put output there. Oh well, so this is one of the problems of using this method. This is why you would script this. Let me just put this in real quick. I'm surprised that didn't fail. Now I don't know where it wrote to. It wrote to the directory. That's should not have happened. Okay, so this should refresh in a second. I should get an output file here. But if I want to say, hey, let's compare these things, I can use, in this case, this editor, this IDE happens to have a compare files feature, and your editor might not. You can use simple diffing tools. It doesn't matter. You can use whatever you want to, and I can see here 95% versus 97%. Now I'm actually doing some science. I mean, I'm actually doing, I was doing science before, but I'm actually recording what I'm doing. And I have a high degree of confidence, apart from making mistakes down here, which I would automate away. And if I want to do a comparison of the code changes, I can see what changed here. Now, a lot of people do this already. But when you're doing the sort of operation-oriented development, for lack of a better word, this really kind of becomes part of what you do, is how you work. And running things quickly gets you sort of in this mentality. It's okay to run these things end to end all the time, because you're not sitting around waiting all the time. And in this case, we're measuring accuracy, but we might have another metric that measures, did this thing run, even though we're running it for for one epoch, we have some other way of vetting the quality of that. And indeed we did. We saw anywhere from 0.2 to 0.4 to 0.6 accuracy. If it was 0, maybe we would complain about it. Maybe we would have a problem. If there's a syntax error, we certainly, or another data shape error, we could stop and fix that immediately. Okay, so that was a big jump. I went from a notebook now to this thing, but the same idea applies. I'm running this thing through, and I'm rather than looking at the result and saying, with my finger in the wind, yeah, it seems about right, I'm actually doing measurement so that I can truly, and if I want to go back in time, I can see what happened. So I think with this very simple move into this simple system, I think I've bought a lot of actual scientific method in my data science work. All right, what are the thoughts on that? Does anyone do this kind of thing? And if you don't, do you use tricks in Notebook to capture results and record results? Do you copy your results into a spreadsheet? I know people do that. Maybe you take a screenshot of it. Actually, that wouldn't be a bad idea. That's actually not a bad idea. It seems absurd, But really what you want is to be able to go back and look at something. Now, it's kind of a bad idea. But I mean, for my example, I could certainly have taken a screenshot of that and it would be perfectly fine. It would have been perfectly fine. There's a way to convert notebooks into a PI file. Yeah, exactly. You could do something like that. Right, exactly. Yeah, you have some sort of, absolutely right. So another way would be, rather than doing save as, you have a little script that goes and dumps the state of that notebook to a file for preservation. I think that would be a very good approach. You know, if you were stuck with notebooks, which you know, a lot of people are. Cool smile here on the screenshot. Yeah. Pandoc library. Oh, yeah, for a PDF. Well, so the problem with PDFs is you're going to have a hell of a time diffing those or getting the information. You'd have to literally be visually diffing those every time. So for code diffing and hyperparameter diffing, or let me show you Guild real quick, and then we can wrap up and answer any questions. So Guild is basically doing what you saw me do with the directory stuff. So Guild, if you go to guild.ai, as I'm doing this, you can kind of get a better feel of what the tool is and what it does. But let me just show you the same kind of equivalent process in Guild. So what I did there is I created some directories and I manually copied the source code in, and I manually redirected the output to those directories. If you use Guild, you can do this. You can say Guild run train 10-second. And kind of in the spirit of what Linus was talking about, where you make something easy, there's a lot of engineering effort that goes into Guild to make what I'm about to show you work. What I'm doing is very, very simple. There's no databases installed. This isn't talking to a server. It's going to run the code completely unmodified. So I hit enter there, and now Guild went and inspected that Python file. It inferred the existence of these hyperparameters. It certainly sometimes gets some of these wrong, but what it did here is it looked to see, you know, are there global variables that look like what Guild calls flags, and then it says, oh yeah, some flags here, and then it exposes those to be configured. So I can actually change these on the command line, but I'm going to use this as a baseline. I'm actually going to label this. I'm going to tag this with the term baseline, and I'm going to do the same. This is the same demo. All right. So this is going to run the unmodified Python. So same as running with Python. Under the covers, this is just running Python. And it's doing what I showed you manually, but it's doing a lot more of it. Oh, I had, that's not baseline. That's fine. So that was Epochs 2. That was not Epochs 5. So baseline would have been this. So I'm actually going to just really quickly redo this. Using Emacs commands, it runs. So what was created here is a run, and it literally created a directory and it put stuff into that directory, but it provides a series of commands on top of that directory. So you're not mucking around with actual directories, but that's all it is. In fact, you can see the directory here. It's in the virtual environment under .guild runs, and that's the run. So that was the run directory that I would have otherwise manually created. And as an example, here's the output. Right. So it saves the output. It saves it a little bit cleaner than T does there. So let me delete that. So I can do things like deleting it. I can back things up. I can do all sorts of fun things. Let me just run this again. Does that work? Oh, yeah, it does. Nice. Guild run, whatever. I don't even know what I just did here. Sorry. It's getting fancy with reverse search. That wasn't a good idea. Train, 10-second, tag, actual baseline. And the other, you know, when you have, I'm trying to think here. This is really, the intention of this is not a sales pitch to Guild. It really is a sales pitch for a method which is to start thinking about your work in terms of operations that you can run quickly if needed and as needed for development mode, flip over to a production workload, all the while measuring and knowing what your inputs and outputs are for every single time you do that. I just feel it's a missing cog here. There are other tools that do this kind of thing, but they're more invasive. You've got to kind of modify your code and use libraries and have network connections or databases installed and other things. So I feel like those are kind of get complicated. But obviously you can do this with notebooks. We talked about some methods there. You could do this manually. I frankly, I don't want to short sell the manual approach. If you feel like a tool is not, you don't want to use another tool, you can write a simple script to go do this. Or you can use, I feel Guild is a strong contender here for doing this stuff, but you might not like it. This is open source, by the way, so there's no, I'm not trying to like sell. There's no salesmanship going here. I feel it's a good tool. Take a look at it. If you don't like it, use something else. But at any point, I think being able to rapidly experiment. As I'm talking, let me do that. Let me actually do a rapid experiment. I'll show you something kind of cool here. Try in a second. I have these hyperparameters. I feel like I want to just use them. So I'm going to say epochs equals 2. And Guild lets you do cool things like, not that, learning rate equals, I'm going to play around with learning rate. So those are the 4 learning rates or 3 learning rates that I didn't really take a look at. And I'm going to just play around with dropout. 0.4, 0.6. So when you're doing this work, a lot of the question is going to be, what if I try different hyperparameters? How does this thing work with different hyperparameters? So what Guild is going to do is run a short switch statement for the. Let me get back to that question in a second. I'm gonna get this started here. So Guild looks at this and says, oh, you're asking me to run with a learning rate with these 3 values and a dropout of these 2. So you actually want to run six trials. And what I'm going to do is I'm going to do that whole trick where I create a unique directory for each one of these things and save all the information. But I'm going to do it for all these different hyperparameters, and I'm just going to do it automatically. So this is going to generate 6 trials. And let me get to this question here. First question, why do you create a new directory for each run instead of just using different names for each output file? Well, you certainly could. It really is the same thing. So the directory is just a namespace for your file. So it would be, now there's huge value in moving groups of files around as a discrete unit. So I mean, to me, it's intuitive to just say, I mean, you want to prefix all the common files, you can certainly do that, but that's kind of what directories are for. So that's why I use directories. Can you use a switch statement for the recurring parameters? A switch statement. I'm not sure what that means. The recurring parameters. If you could maybe clarify your question there, I don't really follow that. What would this look like in the case of deep learning on big input size image sound? Well, it would take longer. Oh, what would this whole method look like? In the case of deep learning, this does become a challenge, and you really have to get invasive into the model to compromise the model. I would say this. If you're not sitting around waiting as you're doing this sort of iterative development, then it's not a problem. So don't worry about it. But if you find yourself sitting around waiting as you're gluing stuff together, right? You're not waiting for a result. You're just waiting for your code. You're waiting to see if a code change worked, right? Then get into it and simplify it, so that simplify the work that you're performing, using something like this 10-second flag, so that you're not sitting around waiting. To me, that's kind of like common sense. Insist on that. If you're running actual workloads, obviously, I mean, maybe not obviously, if you're running legit workloads where you care about the accuracy, you have no choice. You've got to go run it end to end, and then what you want to do is probably have multiple projects running. That's what you do. You have one project for your satellite images, and then you've got a bunch of other things, or What I see a lot of is people will run an experiment and then they'll move on to some other code changes. So they're constantly queuing up work. So they'll run a heavy workload and then immediately get into more experimental work with code. So it would be like flipping this back and forth as you're running. Okay, so I ran my 6 trials. So Marian, I'm sorry if I'm Miss Marian. I want to answer your question, but I don't fully grok it. So if just take a moment to rephrase or something and help me get this, I'll be happy to answer it. So here are my runs, and I'm going to show you one thing I'm going to finish. I'm going to use this is cool. I'm going to have to switch. Guild integrates TensorBoard, and this is an example of when you have your experiment sitting in an accessible easy to access format, like a directory with some files in it. You can start to layer functionality onto it. You can start to layer analysis. You can start to layer diffing and comparison tools. This is an example of layering TensorBoard, which lets you do this cool stuff. So check this out. Does everyone see TensorBoard right now? Yep. Yes, no?
Yep, I can see that.
Okay, great. Okay, so this is a parallel coordinates view, and it's a very useful view when you're doing, you're doing hyperparameter tuning, but also you're just running experiments. You just want to see how things are affecting your goal. Your goal here, your objective here would be, we're going to call it accuracy. So I hid loss. I don't care about loss. I'm only interested in accuracy. So what we're seeing here are each path represents an experiment. So I have my dropout, epochs, hidden layer count, hidden layer size. These really didn't change, so maybe I'll hide those. The hidden layers didn't change in my experiment, so I don't care to analyze these. But we can see here, looking at accuracy, and if I was interested in trying different architectures or hyperparameters, all this stuff would land here, and I can take a look at what is the highest accuracy and by what margin. So like this looks like a pretty strong winner here. It took the longest to run. We can see that the learning rate was 0.001. That's the default. We trained for 5 epochs, and it was, so this is the default. I believe that Google went and tuned these hyperparameters, and the default learning rate for this for MNIST. I think my suspicion is that defaults across all frameworks were tuned on MNIST. So I've not been able to actually improve these hyperparameters with any search. Your data, your models will be a totally different story. You're going to be interested in getting a handle on your hyperparameters and experimenting with different model architectures, different representations, different learning algorithms. And as soon as you start to move into this sort of operation-centered mode, you have a really good shot at capturing the information that's going to drive pointed improvements to your model as quickly as possible. That is really the point of this entire exercise. And when you look at operations and try to drive those operations down to 10 seconds or less, in this case, we are looking at proper workloads. But we also earlier were looking at quick iterative changes. This is all part of the same story. So you want to be able to make these changes quickly, have some degree of confidence that what you did didn't totally break your logic. And so you flip your setting back over to false, right? You turn off 10 seconds, you run it full. Oh, look, I compared my baseline to my refactored and I got the same result. I'm pretty happy with this. And if there was a bug, and you start actually keeping track of your source code and keeping track of all the other inputs, you have an ability to perform a post-mortem analysis to figure out, was there a bug, or if there's some great performance improvement, what possibly could have caused that performance improvement, or there was a regression, what possibly could have caused that regression. Without measuring like this formally around the sort of operational motif, I just think you have a hard time doing proper science. And I apologize, it's a very heavy-handed statement to make, but gosh darn it, I feel like I don't know how you get around it. If you're not doing this kind of measurement, I just don't see how you can confidently say, this is what I'm doing. So yeah. So anyway, this gives you hopefully a mental framework. There's some instructions here on how to do this in terms of the 10-second rule. I'll make these slides available. Let me get back to the slides. Actually, is there anything else? No. I'll just stop sharing. That was a long presentation. I apologize for the length of that. Is anyone still left? Is anyone still there? It's recorded. Just fast forward through it.
Thank you for doing that. Did we get all the questions and everything?
I feel like, oh, here we go. A switch statement executes the code faster, allowing you to run. Okay. So, I mean, when I see the word switch in cases, yeah, you need to test for multiple conditions running. Oh, no. Well, Python doesn't have a switch statement. And you talked to Guido and Rosma about that. He believes in that it's a better construct to use if else. But no, I wouldn't. I mean, in Python, you would use if else. That's just the way that works structurally. And as far as speed, I don't know. If you're asking about the execution time of Python and that, it's not measurable. All your tips make sense. Great, thank you. Okay, if there are any other questions, feel free to chime in. Otherwise, Thomas, I'll let you do the honors of wrapping up.
All right, thank you, and thanks everyone for coming, and thank you for your time. We try to hold these talks to keep people to keep furthering their learning, and if you came here, you all done that today, so good job. If you haven't already, please make sure to subscribe to our YouTube channel and comment what you thought about today's meetup or what you think about our online Zoom format. Also, please join us for our next scheduled meetup on August 19th, where we'll be having a talk on solar learning to rank non-search as a machine learning problem. Thanks, everyone, and have a good night.
Thanks everyone for staying up. I know there's a lot of people from around the world here, and I guess I sometimes I forget that, and I really appreciate all over the place and at ungodly hours. So thank you for taking your time to join us here. Appreciate it.
Yeah, thank you so much. Everyone have a good night.